Hi everyone. In today's lesson we're going to be learning about something called numeric casting. Now you may have noticed when you're working with ints and you perform division, some kind of strange things can happen with your decimal places. It kind of looks like numbers are being rounded, but then occasionally it looks like they're not being rounded correctly. Well, in this lesson we're going to talk about why that's happening and how you can kind of predict what might happen. But then we're also going to give you a tool that allows you to avoid those problems. And this basically is a way of casting from different data types. So what casting means is it's when you force Java to change something from one data type into another. In this case, we're casting between ints and doubles. So we're going to show you the tools that you need to do this, and then some problems that you can actually solve correctly now that you have those tools. Okay, let's get started with a critical thinking exercise. So I want you to take a minute, go through these 4 lines of code, and ask yourself, is this legal? Will Java be okay with us running this code? Will it let us compile this code? If you think yes, then circle yes. If you think no, then circle no or write down a no. There are no points assigned for this, so just try your best and try to think about why you believe that Java will be okay with this. Feel free to pause the video here and then take your time figuring these out. So let's look at the first line. Int x equals 7. Standard declaration of an int. Yes, this is good. Second line here. Int x equals 8.2. Okay, so in this case, if we were looking at this, we might think, all right, this is a double, but this is an int. Maybe we'll just round this down and store 8 into this integer. But that's actually going to be losing some information, right? We're losing the 0.2 if we do that. And we're not accurately storing this value into an int. And so Java is going to look at this and say, no, this is not an okay line of code. I can't take a double and store it as an int without losing information, so I'm not going to do that for you. I will not compile this code. No. The third line. This says int x equals 9.0. Okay, so in this case, if we convert 9.0 into 9, they have the exact same value, right? So technically, Java's not losing any information if it stores this as an int. And we would look at this and we would say, oh, 9.0, they're the same. The thing is that humans are actually more flexible thinkers than computers, okay? Computers have very strict rules and they always follow those rules. And so this line of code violates the same rule as this line of code. You cannot store a double into an int. And so Java will not run this. No. Okay, our last line of code here, double n equals 18. This is an interesting one because Java's going to look at this and say, okay, this is an int, this is a double. But if I just add a 0.0 onto this 18, then I can save it into a double and we won't lose any information. And so yes, Java's going to be okay with this line. So you might be thinking, but no, line 3 was the same thing. So how come Java couldn't just figure out that this would be okay also? Well, the thing is about saving an int as a double is that every int can be stored as a double without losing information. Some doubles could be stored as ints without losing info, but other doubles cannot. And so Java has a universal rule that you can store an int as a double, but not a double as an int. So let's talk about why that is. When you're changing one data type to another, it's all about memory size. Java is interested in whether or not the data types are the same size or if one is larger than the other. And so the reason that this line of code works is that an int is a smaller data type than a double. And so Java knows that it will be able to fit all this information into this variable. And so it lets us do that. This is called a widening conversion because you're going from a smaller data type to a larger data type. We call that widening as a conversion. So changing one type to another explicitly, like in that last example, Java did it for us. When we want to explicitly say, hey, I'm okay with losing information, just convert this data type for me, we call this casting, and we have a special command to let Java know that we're okay with losing data. And so this is the way that's going to look. If you want to convert a double to an int, we need to put the data type that we want to cast our value into in parentheses, and then Java will let us store it into our variable here. So this is going to actually cast this value to 3. It will just cut off the entire decimal portion. That's called truncating. And then save it as an int. We are going to talk a little bit more about truncating in video 3. So when we do this conversion from a double to an int, where you have to cast the data type, this is called a narrowing conversion, right? It's the opposite of a widening conversion because now you're going from a larger data type to a smaller data type. Okay, now let's play around with the code a little bit and do a quick demo of some ways that casting might be useful.